From early system synchronization methods like the network time protocol, now one of the oldest internet protocols in current use, to Lampert clocks, the first implementation of a logical clock algorithm, to modern solutions like Google's TrueTime API, which uses atomic clocks to synchronize faraway databases, consistency through synchrony has powered the growth of large and complex global networks. In a truly distributed web, we can't give an atomic clock to every machine in our network, or assure that every atomic clock keeper is honest. So we've had to adopt an even more radical strategy to achieve consensus across the many and diverse nodes in our network, using randomness as a pathway to consistency. In our quest for strong randomness, we're building on a robust body of prior art in the field of randomness engineering, with some extraordinarily creative solutions. For example, the United States' National Institute of Standards and Technology, NIST, has a project that aims to produce randomness using quantum entanglement, otherwise known as spooky action at a distance. Bitcoin can produce random numbers by broadcasting random values every time new blocks are mined. And the RandHound project has created a robust and scalable random number generator. The distributed systems of Web 3.0 require a source of randomness that is unbiased by any party to operate optimally. And today, we'll hear from speakers deeply involved in creating the tools to make our random web work. Now let's talk about good randomness. The Randomness Summit is part of a celebration of the launch of DRAND version 1.0, the internet's first production-grade, publicly verifiable randomness beacon by the League of Entropy. DRAND was developed as a response to the question, can we make fetching randomness as simple as fetching time from NTP servers? DRAND is decentralized. Its output is produced by a diverse and active network of independent parties, the League of Entropy, who are committed to publicly generating good randomness. Good randomness is extremely important to the protocols binding our information networks together, and we will hear more about why that's true in today's meeting. But what is good randomness? Well, we can start by describing its opposite. There have been cases where attackers have rigged lotteries and elections by influencing the randomness of a system. Insecure, exploitable randomness is bad randomness. Randomness researchers have defined 5 characteristics that a random number generator should have to mitigate these types of exploits. It should be unpredictable, which means that you can't reliably guess the next number to come out of the generator. It should be publicly verifiable, which means that anyone can check that a random number is a legitimately random number. It should be bias resistant, meaning that you can't lead the generator one way or another. It should be decentralized, so there's a set of independent parties that produce the random numbers. And it should always be available. You must always be able to reach the system to get a random number. DRAND is a distributed, bias-resistant, unpredictable, always-on, and publicly verifiable source of randomness. Today, we'll hear why randomness beacons like DRAND are integral to the future of the distributed web.